Okay, so let's start. So before we start, I still wish to quickly go through the teaching plans for this course. So last week we have introduced the fundamentals of the programming with the Pythons, right? So also we introduced a little bit how to use those AI tools for the programming stuffs. And still for this week, we are going to continue with the fundamentals for programming together with the examples with the slangs and also introduce another tools. It's called robotics operation system. So ROS. So this is a very important, platforms or toolbox for research on the unmanned autonomous systems. No matter you are talking about the slang or talking about like artificial intelligence for unmanned autonomous systems. So this roughly for today. And probably by next week, we are going to have our first assignments. So assignments may related to the programming. For example, like generate the basic codes for analysis of some data. So next week we going to talk about the unmanned autonomous systems. For example, the drones, the sensors, roughly goes through the controls, path plannings for unmanned autonomous systems, and have you provide you with quick figures about how the systems looks like and what it should be included in the systems. And week 7, okay, we are going to have a lab sessions. So lab sessions are going to be related to what you have learned in the past weeks. And okay, week 8, we are going to have midterm. So midterm is going to be closed book. Okay, midterm is going to be closed book. Final exam is going to open book. Okay. So any questions for the teaching plan here? No? Okay, great. Okay, so as I remind you for several times, so each of the lectures, we need to make sure you have take the laptops, okay? Make sure you have take laptops. So quickly go through what you have learned in the last week. So last week we introduced the basics. So as we mentioned in the last week, majority of you already have some backgrounds in Python programming, right? So for example, the installation of the Python. And so last week, anyone still did not finish the installation of the Python and VS Code in your laptop? No? So very important for this week. So if you install a ROS, sorry, if you install the Python, install the IDE like the VS Code, and quickly go through several example codes for okay, definition of variables and several data types. For example, today we are going to use basically like the integer and float numbers, variables, booleans, and basic operations like, okay, of course, the addition stuffs, divisions, modules, and exponentials. And also you mentioned a control, right? Control functions. For example, you want to make some based on different conditions for different results, for different code blocks, and provide some questions, solutions, list for loops. Okay, the for loops and while loops to iterate a vector or iterate a list or tuple. So loops and also examples. Okay, provide. Okay, so functions is very important. So for example, if you want to organize the code blocks to finish a given task, okay? So for example, calculate the roots of the quadratic functions. For example, calculate the solutions of the sine, cosine, the inverse of the matrix. So this is a very specific functions. So this can be achieved by defining the functions, okay, in the Python programming. So this is also very important. So for example, local variables and the global variables. So for example, if the variable is defined in within functions, okay, so of course this is, it only exists, okay, so why within those functions? So if the variable is defined outside a function, so usually it's defined like global variables. So it will survive, okay, throughout this code. So for example, this one is global variables. Okay, it's outside the functions. So basically, if you get into this functions, okay, this variable is different from this one. and this one will override this one. Okay, take over this one. So this is global variables. This is local variables. So for those variables, they have different lifetimes. Data structures. For example, like if you read a series of data, right? If you do data analysis, for example, series time series data, you need to save those data. For example, for different timestamps, okay, you have different data. So how to save those data and how to process those data. So you need to use those data types like lists, dictionaries. For example, like for each of students, okay, you have names. For each of students, for example, if I want to also record your like GPAs or the age of each year. So for example, Dr. 1, 20, maybe 30 something. So it means, for example, this one, okay? This is the keys for dictionary, okay? So this is the values for this keys. So this is a very useful or convenient data types for the process of data. So this is the question we, for example, like last week we say, okay, so which name have existed for most of the times? Of course, should be maybe Alice, 3 times for Alice. So to solve this problem, okay, you can use the dictionary data type to solve this. So this is a reference answers to find out which name have existed for most of the times. So of course, the Alice 3 times. So some modules like the like a mathematical toolbox. So it just one line, important math. So you can enjoy all the functionalities included in those math libraries, like a lot of sine functions, like a lot of cosine functions and explanation function stuffs. You can enjoy those functions just one line. Another one is NumPy. So NumPy is numerical Python. So it means you're talking about the numerical calculations for example, if you're talking about CFD, okay, so a lot of numerical calculations. And also later this week, we're talking about the slangs. You have a lot of calculations of the metrics. So the NumPy is a toolbox for the calculation, especially designed for the metrics stuffs. Okay, this is from NumPy. So Pandas is a toolbox for the Pandas is a toolbox for the process of the data. Okay, process of the data. So for example, this is an example to calculate the inverse of a matrix. Okay, so let's move from this task. Okay, so for today, so in here we provide this is a CSV file. Okay, so this actually it's a trajectories of robots. So first line, this is the timestamps. This is time, okay? Timestamps represented by the Unix time, okay? By Ubuntu Unix time. So this line is the positions X, Y, Z, okay? So this is continuous. So later on, I will have one slide to introduce how to use the continuous to represent, okay, represent the orientations. So those 4 variables is associated with the row, pitch, and yaw orientations. Last 3 columns is represents the velocities. Okay, the velocities corresponding to the one for robots. So what I want you to do is to plot the results. So for example, I wish you to plot the trajectories based on X, Y, Z, right? And also plot the velocities and also continuous like the pitch, roll, and yaw angles. So the procedure is roughly like import the head files. So for example, you need to process read the data. Okay, we can import the library pandas. Okay, especially used for process of data. So the second one is matplotlib. We mentioned in the very beginning week. This is the libraries for the plotting of the data. And NPL, this is toolbox for the processing of the we say it's computer vision or the prographics. So last one is the transform. For example, in here we have orientations, right? So we need to do some transformation steps. So this is an example. For example, why we need to at the beginning learn how to read the CSV. So for example, in the coming weeks, we're talking about machine learning, right? So it's about data. So for example, we have a department is data science, right? So it's about data. Okay, we train a model, it's about data. So we need to read or decode the CSV files. Okay, this is the beginning steps. So we provide the data. The data can be found through this link. Okay, so the link is actually we can find the data at this repository. So any of you don't know how to find this repository, also can find this repository through this link. Okay. So actually in this is okay, let's go back to the main photo. So this is the code, right? So code for the week 3. Okay. In the week 3, you should have some okay, this is 260 bars. So solution 1 and solution 2 is associated with so this is associated with global objectives. Global objectives. So let's finish the first one, the first task, okay? Let's finish the first task first. So please, I can demonstrate for one time so you can use this level quickly. After you say if you are not, then you can try. So the objective I'm making if I'm doing this knowledge based on the time one, just to be taken. And also, I mean, problem we need to get that. So just have a change and get and just have to focus it now. So you can try yourself first. Also, I will do this, okay, in this computer with the ChatGPT first, okay? So for example, okay, in the Polio, we'll say AI service, okay, we have several toolbox. So for example, you can try the GPT 4.0. So this is, I mean, very smart in writing reports. And actually for the, if you are talking about reasoning, so for example, if you want to do some solving some complicated task, okay, the O3 is the best option. Okay, O3 is the best option. So if you want to do the coding stuffs, okay, so I talking about the resources you can have access from this page, okay. So Copilot is the one you should be most happy with, especially when talking about coding stuffs. If you do the codings, right, Copilot is the best option. So you can try Copilot with Bing, okay, for the coding. And also you can ask the ChatGPT 4.0 for the coding to solve this problem as well. Okay, because the problem we just mentioned to plot trajectory is very simple, okay? GPT 4.0 can solve it already, okay? For example, if I solve this question, so this is like, okay, today, okay, you go to the company, okay, so okay, this is the new data. We have done, okay, so this process the data and so it's lost. And this is lost. So okay, take this like here before the normalization. Okay, we push down before. That goes to find the so from now on, okay, you can let's do us. Maybe just 20 minutes. Generate. So okay, for example, like okay, in here, 1, 2, 3. How many colors do you have? Okay, for example, I just like the just like talk with the ChatGPT. So 1, 2, 3, 4, 8. Okay, in this case we have yeah 11. First column is the time. The second one is XY. The second is so maybe something like this. Okay, so when I prepare the slide, my prompts or my questions different. Okay, maybe for different questions you get different results. You need to do some fine tunings. So the code is very straightforward. Okay, the first one is then change your name is your file C3, and the second row is like you need to change the, I mean, change the string variables like timestamp variables with those like okay, you need to change it with time, post x with those variables, change with this one, and then you copy the code to base code, okay? And also we can try another toolbox. So just like you mentioned, like in portfolio service, we get so if you ask the DeepSeek, and also in this course, okay? So in this course, personally, I think it's fully okay if you use DeepSeek or ChatGPT to help you to generate a report. I think it's okay, but still I need to, I mean, identify your innovations and your personal thinkings. I still need to identify this. So if you use the DeepSeek, you're going to see the details how the DeepSeek consider these questions, think about these questions. You can see everything how the DeepSeek thinks. So just my question is talking about the 2D case, right? So also if you want to plot the 3D case, plot X, Y, Z, so what should you do? What kind of codes you need to change? So for example, I mean results output file DeepSeek, so it's kind of more detailed, more comprehensive. So for example, it generates a design function, okay, design function to do the proteins. So for example, also for the usage, it requires you to I mean install pandas and matplotlib. So of course I think you have installed this before maybe. It's very detailed, okay? It's very detailed. Okay, please do this. Okay, 10 minutes. You can use the DeepSeek. Also, you can try this. Another one is called Copilot. Okay, you can try this one. So this one is specifically designed for the coding stuff. Okay, let's do box, do the codes. So for the copilot, you cannot, it will not provide you the thinking process. Okay, so let me provide you the result. Let's move forward. Okay, it should be 100% correct. see the differences. Okay, plot the true trajectory. So in the graph, you can find, okay, the portrait and the photo in a 255. So, for example, the first line, say, action or label at the same time. So the second line, you can use the policy for the project. So this is what you expect to get. So if you have finished the second one, okay, try to finish the last one. Okay, plot the so subplots. Okay, one plot state to up down, one to my two, and this is the matrix, and this is the chain of the X Y Z. Okay, with that. So last week we have introduced the deployment of logistics in a laptop. So after the course, have you ever tried to deploy a large model in your laptop or in your desktop? For example, like 10 billion, larger than 10 billion, before. So for example, recently, okay, so the logistics kind of packages because a lot of people are hack the logistics. So you can, if you have money, you can install a large model of the district to your desktop at home and provide a service to and the technology and account with your desktop provider service. Okay, so let's move on. So if you have finished this, you are going to get you'll get a trajectory like this. So this is a 2D case, X, Y. So also you can plot plot this. Okay, upper left figures with a 3D case. Okay, you can upload figure with a 3D case as well. So also we provide the example codes. So you can find the example codes from this repository. Okay, so there is a EVA post, evaluate post. So this PY files can help you to provide with. So that's the details. So I copy the code to the VS Code, and you save the data. And if you run results, yeah, 1 second. Okay, so if you run results, you run code, you're going to get the results like this. Okay, so this is the Y, and for corresponding to the two solution files, right? This is Z, and this is X, and this is XY plot. So let's look into the code. So at the beginning, you need to okay, import several libraries like the pandas for the data input and output. And the matplotlib, so this is used for the proteins of the figures of the data. So the third one is the 3D. Okay, matplot 3D. So for example, if you want to plot the 3D cases, 3D XYZ plots, you need to import this one as well. So last one is about rotations. So because in here I also this example code I also provide the plotting of the orientations as well. So first, you need to set up the photos. So this is the string variables, right? To set up the photos of the files, okay? Two files, two photos, right? Python, the solution one, solution two. So at the beginning, so PD is the pandas, right? Read the CSV, okay? So save this to the data one and set this to the data two. And next one is to get to the first columns, okay? Get to the first columns. The first column is corresponding to the time, so you can find the SCP data. So okay, so the first line, okay, let's say time, let's say POX corresponding to position in X directions. So this is more like a key, okay, the key, and you try to get based on the key, you try to get the values, and okay, the next one is going to be post one. Let's say variables to save the position and velocities. And for the second data, so also in here we save the continuous XYZ W corresponding to the continuum data. So this is associated with the roll and pitch yaw angles as well. So this is the equations to function to convert the continuous to the Euclidean angles, for example, roll, pitch, and yaw angles. So this one should be introduced in the frame mechanism and control. So later on, we have several quick slide to introduce this one, okay? So let's see function to plot. So subplots means tries to split the, okay, split one windows into 2x2 matrix windows, okay, 2x2. So for example, you want to plot the x, y, and like x, y, z, and the trajectory in the same windows. Okay, you need to have to four sub windows. So this line is to split the windows. So for the first plot, okay, plot the x and the y to get a trajectory. So this is corresponding to upper left, okay, corresponding to the upper left. And later on, you need to set up the captions of those x and y, set up the titles, x labels, y labels. And for the second subplot is about time corresponding to x. So this is upper right, okay? The figures on the upper right. So this is upper left is low left, this is corresponding to X, sorry, corresponding to Y, and this one is corresponding to Z, okay, corresponding to Z. So this is the proteins. So third plot, fourth plot, and okay, short figures and save it. Save it with this name. So any questions for this? Nope. Okay, so let's move on to the next part. Okay, so the next part is about the slang. Okay, about the slang. So before we start, so any of you have already read the slide to get some supplementary background knowledge about slang? Hands up. No, about slang. So, to teach you the slang, so that's going to be a course actually. I mean, to be honest, if you want to teach the simultaneous localization, mapping the slang technology from scratch, it's going to be like one semester course. So from state estimation to modeling to estimation to optimization steps. So in here, I try to introduce this in like maybe 2 hours. So in here, I will start from the results. Okay, to let you know what is the results of the slang looks like. The results is coming from the SOTA, okay, the state of on slang algorithms. So then I go back from scratch. Okay, scratch. Like for example, based on Python. So we do the slang based on very basic slang algorithms. And then go to ROS with C double plus and gradually go to the state of on, like a LiDAR slang with the Liu-Sen algorithm. So let's take a look how the slang looks like, okay? So first of all, okay, so we have a data. So in this laptop, I have installed a ROS already. So let's okay. So this is a terminals. Okay, the command lines, command windows to input the to interact with the laptops, right? Interact with the Ubuntu system or ROS system. So this is a Ubuntu system. Okay. So several commands. AS. So AS means you're going to see what you have in this folder. Okay. So later on, you can go back to the video recording if you want to like. So AS is just very simple commands you need to learn to remember is good enough. Okay, AS to see what you have in this photo. So see we have a lot of BAG file. So BAG file is a ROS data saving format. Okay, so for example in here, okay, I have a several data formats. Oh, sorry, several row spec. So for example, the open name. Okay, this is a PolyU open source data sets. HK is Hong Kong. Okay, TST is okay, very close to Hong Kong, close to PolyU, and this is the year and the month, date, census spec. So let's take a look what we have in the spec. So the command for this spec play. Okay, so spec play is to open or play the spec, play the files. Okay, play the files. If you play it, okay. If you play this, you are going to get a lot of data. Okay, so speaking of the duration, you have place disciplines, but in total, it's about like 10 minutes of data. 10 minutes of data. I think it. So this is the content. So this number is big. This number is coming from the bulk data of the quantum system. That's why it's bigger. Okay, duration. So how to visualize the data? So I cannot see anything in here, right? So to visualize the data, there's a toolbox. There's a toolbox. Okay, no worries. Later on, I will let you try. RVIZ. So this is R is ROS. VIZ is visualization. What's visualization? RVIZ, this is toolbox. Okay. So if you open this, you're going to get this toolbox. There's an add in the lower left, and several topics topics means the data. Okay, so for example, okay, okay, so in this case, you're going to see those data as well. So the car is driving. So also let me show you the image. So the car is driving, right? So let's say TST. So from the view of proximity lidar, so you see a lot of control, right? And for example, the lidar is on my bottom of my head. Okay, you just do the image, right? So move forward. So you see a lot of contrast. Okay, you can see this lidar is. So you can see, I mean, from the view of proximity lidar, you can see everything. Where is the front and where on back? So the line of lane or like simultaneous propagation and mapping. So the line of lane algorithm tries to estimate the trajectories, and simultaneously use the map. So it's two things, simultaneously propagation and mapping. So for propagation, we take everything. So the two methods are the control map. Control, like zero point, different map. So that is the image. What are the image can be similar thing? So accuracy on top not really light up because the image can be easily be recorded with several years before I would say the image is not very good. Some models have large models and not say it's a big problem. Because the light actually identify it as a light. So it's like AI, it in your brain. So that's what they're not correct. I mean, LiDAR is good, camera is good, I would say. So the objective of the LiDAR today is to estimate the trajectory and bring the map. Okay, so this is your node node to play the data. So let me build the map for you. Okay. Okay, clear. Clear everything. Okay. So in here, okay, let's command to run the algorithms. Okay, let's LiDAR scan algorithms. Okay. And also you're going to see this windows, right? Okay, nothing here as well. Because I didn't play the data. So if I play the data, you're going to see some like see the maps. Okay, so this is I mean, okay, it's moving. So you get the trajectories, you see? You get trajectories. So this is solely estimated by the algorithm. The algorithm that this blue line, so blue curve represents the trajectories and also get the map. So let me show you the maps. Okay, you see? The map is accumulated of the environments. So this is the output. This is what we expected from LiDAR scans. So for example, yeah, because this is my laptop, it's weak. So okay, keep crazy. Okay, it's regulatory generation maps and also estimated effective. So what this can be used? Okay, computer model for down to 30 design down to the how it can do the so if you are talking about the role scenario, you can generate the capability map of the role time. So from that, we can say inverse the factor area, what's my difference? So this is a new concept. New concept. This is the already machine learning tool. So initially, what is the 3D image? Well, I so we can look into the scenario. Yeah, it's like a clear camera. So we can censor that. So for example, like this, or like we like say, okay, let's do about like how that correct or accurate. Well, it's provided that. So a lot of things with very AI and machine learning, not no sense of that. Including problem. So let's see, information on the future we are going to see with the new area. Well, future is very what the one we think in the future? Okay, it's not okay, so he says in the future, okay, what is the happen as we enter the 3D dimension? Okay, like the lab, 3D dimension. So we are at the exactly what we are what it is. So for example, we have here and okay, we have this of 3D dimension. So part of the problem is that existing copyright software, they are familiar with the image and can create any between information. So what about this? So for example, in the future, we have two not so luckily I think about so luckily I was on this kid. So it's around like the other crop in life I thinking of it. So I will back to reflection the vector moving back a robot. That's not the moment people so the moment is just like the most of the 20 years we have 600. So I think it's interesting. So I think this is under our life, for example, okay? So this the code, in compiler code, generator code, and for error, you probably add to the core, probably not the accurate for the code. You can actually debug the code and fix the code. For example, okay, this place you know, okay, so like the finger, not me. Okay, not finger, okay? And mostly, like I think okay, they go before. Okay, oh, the code is high. Okay, after the code is wrong. Okay, then you say, okay, something wrong. Oh, the timing is not correct. Okay. Oh, it's okay. So I guess you will know then the code is in there. We upload the code and let's go out and fix it and take it. Okay. So the difference in infection, we're going to add the sensor. Here I go on the technical part. Okay, human mode has 10, and so that's the problem, right? Three information. This is for terminal okay. So if we have a 3D condition, and two level information to the physics, to the flight model, this is so that's why this is a big one. Back to the data is the one of the content. So I think the so in this case, basically in the federal research, the business as the data is very So this is the we're going to achieve finally. So let's go back to the slide. Okay, start from scratch. So just now you have a quick sense. Just now you have a quick sense. Okay, about what we're going to achieve. Okay, with the LiDAR sense, right? Already have a sense, right? Rough sense about what we're going to achieve with LiDAR sense. So to achieve the LiDAR sense, so the iterative closest point is the most principal theories behind. So for example, okay, if the LiDAR slam problem is the robots move forwards, continuously capture environments. It's like a 3D point cross, right? The color points I just mentioned to you. So if we simplify the 3D point cross, it's going to be like the blue. Okay, this is blue counters or the boundaries. Okay, blue one and red one. So blue one and red one is the major differences is the data is collected from two different positions, maybe like two continuous positions. Okay, T1 and T2. So the ICP problem is to find a transformation to map the blue, maybe like boundary or curve, back to the red one. So this transformation represents how far you have moved. So let's look into examples like okay, so you can answer question like that. Okay. So the first one is like okay, for example, the head of actual concept is like this. So the next concept is move a little bit, you take a little bit. Why? Because for the robot is moving. Okay, okay, for example, the sensor is installed with the robot. Okay, so if they move over a bit, this person is position. Move it a little bit. This is the problem. So the identity problem is to map the two shapes. Okay, to find the basic template and basic location. Match the two controls. So this template and location is for how you do it. All the things. The two sides of so the two shapes actually template and template location. So this is the problem. Okay, this is the matching process. So the iterate this point is the widely used algorithm to do this by definition. In order to use it and robotics for aligning to the chip or control. So the goal of the ICK is to find the basic information, including including translation, the location, the translation, location. The goal of the ICK is to find the basic information. And let's minimize the differences between the control. Control is like two chips, okay? Differences, if they mesh perfectly together, okay, differences is not it. Okay, so looking to, actually I provide the tutorials here. So from the mathematical view, it's going to be like giving two corresponding point sets. Okay, so a lot of points. For example, in the just not in the RAD, you see a lot of point cloud, the color points. So here two sets of points, x to xn. So each xi represents a point. That's what it is, okay? So output function is to find the base r and t. Base r and t. Okay, to transform the P point set back to the X point set. So generally, this is a function. So this one is going to like the concept, right? Okay. So I try to, so this, for example, I represent this shape with a lot of points. Okay, represent this shape with a lot of points. From S1 to Xi. So for example, I share one pick a lot of points. So for example, this is two shapes. Two shapes can be represented by a lot of points. I try to find the basic match by translate, rotate. Okay, so the basic translate and rotate is represented by the R, is the rotation matrix, T is the translation matrix. Okay, so this is the objective of the ICP. So you can find the details of those. So because I mean, I cannot catch, I cannot cover everything. I mean, in this course, but I provide a very detailed tutorials for ICP. So, like in terms of the including the abstract and introduction. So, and also the theories in details. So, for example, I just mentioned the object function is equation 2. Okay. So actually, I learned this from my friends. My friends is in our university in fun. So he also very efficiently basically teach everything in that part, like cover everything. But always the time is limited. You don't have 24 hours in one paper. So confident they should learn more. So finally provide the tutorial. Okay. So I also try to do that this year. So for example, that's pretty the future. So let's look at something. Yes, the objective is to get the R and T based on this function. So this is here, the solve equation I said. Okay, so if you're interested, you can refer to this tutorial slide and feel free to let me know if you have questions. So several key steps. So the first one is to calculate the correspondence. Okay, because a lot of points. For example, a lot of points. So how to select the most representative points instead of rotating use all the points to make it even more efficient. So the first one is performance estimation. The second one is performance problem and different transformation. Okay, so our this is the variable to optimize R and T for transformation to transform the points together to minimize the distance. And later on, we provide the algorithms, provide the codes. Okay, at the beginning, provide the Python code. Provide the Python code to implement the ICP. So from scratch. Okay, based on some existing libraries. So the second one is this one is to like examples. For example, if you want to understand ICP, then we can know the homogeneous transform. So for example, like I just mentioned, okay, translation first and rotation. Okay, so the two parts can be combined into one homogeneous equation. Homogeneous matrix is a 4x4 matrix. Okay, later on I have examples. So and later on is ICP example is Python, and this is another example. Okay, this is based on another doctor from Japan. So he maintains a very good open source repository as well. Okay, you have code. Okay, you have code. So just now we have roughly mentioned a concept. Okay, so if you can continuously find the basic information between overall. So if you accumulate more information, you get the accumulate the position, you get the. So the problem is like the trajectories we are given. Because it's like the accuracy of the final trajectory depends on the severity. From first concept to second, and then third. So if there are some errors, the interface is more than the severe something, and then there is no way to make it control, make it effective. This is an example. So, for example, this is a very simplified example. So, two series of points, two points, three points, three points, so by using the SAP equation, it's measuring for the line. On the line, first we need to translate to rotate. To find the phase of translation and rotation, line the two points. So, how you get the two series of points to blue and red? So usually it's based on two positions. Because they will simple or social, the moon. So that's why we get different things. So that is very hard. Okay, so let's take try. So anyone didn't have the laptop in Python? No? So let's try. So ask ChatGPT. So Python example for iterative coordinate point as I mentioned. Two polyclones with different colors and show the result of the efficient combination. So if you ask ChatGPT, it will simulate the string control. So for the green and red, it will simulate the data. So the result is going to be like this. So this is the okay. So on the understand this transformation. So this the upper left, the upper right 3x3 matrix. This is the rotation matrix. So this is the translation. So this means if you translate this one, okay, based on this XYZ variable, it will be a kind of match. And when you rotate based on this rotation matrix, it's perfectly aligned. Okay, take try. 10 minutes, keep trying. Like this. So for that, this is a full service contract, right? Yeah, like not for aligned with match. So after one ICT averages, the two contract is for aligned for your time. example, let me try. Okay, so in the repository, also you can find the example codes as well. So in here, okay, so if you look into the ICT folder, so there is a folder called integrated processor point. So in here, this one is generated by the ChatGPT-4. So look into the Tor ICP, okay, Tor ICP here. So the code is available in my laptop. So let me show you this one, okay? Okay, let me share results first. So this is two frames of Hong Kong. So 3-1 and 3-1. So it's like, I mean, even after registration, the Hong Kong is not will not be a match, not be a match together. So this is because I mean after this West African, I think the whole traditional I think is not absolutely not. So for that, that's why I mentioned actually the results of the method based on the quantity. Everything is based on the raw material. And also the conventional but generally. Okay, the general methods. So let's look into the code. So I close the window, it will iterate for several times. Okay, iterate. This is third iterate, fourth, and fifth. So after several iterations, the red points and the color points, it will kind of align to each other. So you see, from this concept, I close the window. Start to create the word. Calculator approach. Lapisan diverge. So here's the identity algorithm and usually they check and development unit. And this is modularity. So for example, if you look at the to the so everything to root of the real different. But algorithm diverge is a root of the fraction. So what is the number where the accurate of correct solution in terms of the system. So if I close the window again, it will gradually diverge. So far away from, yeah, far away. Get more and more far away from. So get further diverge. Okay. So this is very dangerous. I think this is good. This is good feature to see that the argument of the argument and that is very important. So for example, if we make the dynamic system control or the control region. So the stability of the algorithm is very important. So our system comparative is it's not relative for the usage or the system response you expect. Okay. So if you look into the course, it's also very straightforward. So at the very beginning, it will generate the okay, we have two point clouds, right? One is called source, one is called packets. So the two point clouds is generated by the random functions, randoming functions in the Python. So for example, generate like 10,000 of points. And for the source point cloud, it can be obtained by doing some I mean manually. We add some translation location to split the two point clouds at the beginning. And then you can try to use the ICP algorithms to do the matching of the two point clouds to make sure they can match. Okay. So in here it's the iterations, maximum iterations you're going to apply. So for example, I can apply 10,000 iterations. And finally, what you get is this is for iterate 14 times. And finally, you can get the translations and rotations in this transformation matrix. And last, okay, you can draw this result. So this is from ChatGPT, right? So I asked the same questions for the DeepSeek. So my question is quite similar, okay? My question is the same. So Python examples of iterative versus different powers will show those different iterations. So it's good. I copy the code. I copy the code to the Python. I get the results. Okay, let's take a look. This one is much easier to understand. So the the frames of so by using an ICT, like if you're like, okay, you can see the ICT is very good in mind. The average error of the observation is like of the matching is like the only eight is like 8 centimeters, 8 centimeters. So we can come across. So we can tune some parameters in terms of the code. The code is quite similar. So for example, at the beginning, it will okay, it will generate the code. So for example, at the beginning, okay, the default parameter is 50 points. So I indicated sensor. So if you do the song control, so you can copy one, copy the song to the package, and the manually add the translation evaluations. So for the translation is like 7.1. 7.2 to the song control. Manually translate the translation. And try to use the scientific averages and connection to the component. So the foreign part is I mean everything is done from scratch. For example, in here, okay, it will use this is the KD cheese to find the okay. You need to look into my tutorial. The PDF tutorial to understand what is here and complete the system. The system we can use the FAD translation. So the code from DeepSeek is much more in details. I mean, all equations in the tutorial is in detail. So after you get the R matrix, you can get the translation matrix. So finally you get the results. Because as I just mentioned, so I think the algorithm is local get checked into the local minimum. So for example, if I make a big so the angle, I mean in terms of those, I mean the location is like pi over 4, okay? So if I make this to be much larger, like take a look to see if it will still converge or not. Okay, it still converge. I mean, if I add a big error, add a big differences in terms of two controls, it will still converge. It will still converge. So for example, if I add a larger, so let's see the translation. For if I add a big translation, you see it will gradually still converge. So you can you can tune the parameters. So first of all, you can add the similar questions to the DeepSeek, and you get the codes, and you're going to roughly probably get the same codes. And if I add the bigger translations, for example, even like 5 meters, it will still gradually converge. Gradually converge. For example, I add a big one, make 20. It means I try to translate. Okay, make a big differences in terms of the translation of the two controls. It will still gradually converge. You see, it's gradually converge. Okay, so let's try to find the first is the point. So we can match the difference of controls. So you have hierarchy. You know, last year I was trying to do how many things. So this year we can implement with the other things. So for example, I just select the Okay, so this is the two frames of uncross. So let's move back to the slide. So about representation, I'll take break for 2 minutes. Okay, so let's move forward. So question. So have you already learned the orientation representation with continuous before? Continuous already. So which course? Ah, UAV controls. 304? Dynamic system. You are taking a different program? Then so who is the lecturer? From Dr. Helen Huang? Oh, I see. So that's great. So let's quickly go through. Okay. So to represent the pose, it includes the position and orientation. So in robotics, for example, we talking about slants, right? The slant is to estimate the trajectory, the pose. So in robotics and computer graphics, so representing the position and orientation is of an object, for example, jumps in space is crucial for tasks such as navigation, manipulation, like for robot arms and for humanoid robotics, and visualization. So, for example, like position first, okay, we can represent this with Cartesian XYZ. And for the orientations, we have several different tools to represent. For example, your angles. Okay, for example, you could represent the XYZ orientations with roll, pitch, and yaw. And we can represent the orientation with the rotation matrix. So this is consistent or equivalent with the roll and pitch and yaw. So with three by three rotation matrix. And also we can use the continuous to represent, it's going to be a four variables, WXYZ to represent the orientations. So advantage is it's compact. Okay, rotation matrix, we have nine variables, three by three matrix. And with continuous, we get compact representations and no gingo block. And also last one is homogeneous transform. So this homogeneous transform is a 4 by 4 matrix. So it includes the position and the translation in one matrix. Okay, the 3 by 3 together is a 3 by 1. Okay, get the 4 by 4 matrix as a homogeneous transform matrix. So how to transform, how to translate or transform all those different representations. So for example, from XYZ orientation is roll, pitch, and yaw, right? Like, okay, phi theta. So how to transform from your angles, okay, to the 3 by 3 matrix. So this is equations. So based on sine and cosine functions, we can easily transform. For example, this is the, okay, this is your, okay, this for Z, this is your angles, and this is pitch, and this is rolling. So applications can be applied to the double arms and also for the drones. So in terms of the libraries, we can use the NumPy. So NumPy is a numeric Python library. So this is the basic package for the computing and especially for Python. So it can process with n-dimension data. So this is example. So this is example code to I mean to transform. Okay, to represent the orientation from your angles to continuous. So this is WXYZ. Okay. So this is the code to transform this from. But all the things are I mean implemented in the NumPy, so the libraries. You don't need to do everything from scratch. Okay, just one line. You can finish all those transformations to change from your angles to the continuum representations. So in here we provide the examples. Okay, let me directly provide you examples to how you use Python to process or to implement the transformations. So let me show you the examples. But still, okay, if you look into this repository, you can find these codes examples. Okay, you can find the code here. So copy the code to the VS Code. You can choose you're going to see this one, okay? So at the beginning, so if you want to represent the XYZ, if you want to represent XYZ, it's quite straightforward. So numpy array XYZ. So that's to print the position. So the from line 7 is going to be like import a library from scipy. So you're going to get a rotation related functionalities. And from line 10, you're going to have the Euro angles, okay, Euro angles in row, pitch, and yaw. And you can get a rotation matrix, okay? Line 11, you get a rotation matrix from the three row, pitch, and yaw angles. So let's define a rotation matrix. You can define a 3 by 3 matrix, right? So the 3D by 3 matrix principle, the principle is based on the slide. Okay, the principle is based on these equations. Okay, how to represent the 3 by 3 matrix from the three angles, from three angles. And continuous, okay, continuous can be get directly from just one line, okay, based on the functions from NumPy. So rotation as continuous, okay, this function can convert from Euro angles to directly to the continuous. And the transformation homogeneous transformation matrix is 4 by 4. So the first 3 by 3 can be represented by the rotation matrix. And okay, the first column 3 by 1 can be represented by based on the position. So example can be found in the slide. So just now we mentioned ICPs, right? So ICP can output the transformation of the two frames upon cross. So this is a homogeneous transform. So 4 by 4 matrix. So the first 3 by 3 matrix is a rotation matrix. So this is a translation vector XYZ. So the last row is always the same. Okay, 0, 0, 1. Okay, that's why it's called homogeneous. So let's see the, so you can represent the code, okay, based on the code we provide from the GitHub. But as we mentioned just now, so if you use the Python, the performance is always limited. Okay, it's quite slow. So you can do some examples or demonstrations. It's good. But if you want to really implement the Slang algorithms to the real systems, okay, Python is too slow to use, to deploy. So in terms of the definition of Slang, it's like a robot, okay, continuously capture the point cross at different timestamps. So if you do the ICP for a two point cross, right, you get the translation and the rotations for different timestamps, right? You get the transformation matrix. So let's say from T1 to T2, let's see the 4 by 4 matrix. And if you go from T2 to T3, you get another transform. Okay. By accumulate all those transformations, you get the trajectories. Okay, you get the trajectories. So basically, the pipeline is going to be collect the 3D point cross. Okay, the color points is 3D point cross from 3D LiDAR. So LiDAR is a LiDAR sensor. So then you can perform the registration. It means the ICP. Okay, kind of ICP algorithms to get the relative transformations. And last step is to accumulate the posts. Okay, accumulate the posts to do the mapping. Okay, you get the results. So in here is examples from the algorithms I demonstrated to you just now. Okay, so the trajectory, for example, the finalized pose is going to be the transformation from T1 to Tn is finalized timestamps. It's going to be the multiplication of all those transformation metrics, of all those transformation metrics. So let's see another example is like, as I just mentioned to you, so if you set the iteration number to times, so the algorithm will diverge. It will finally diverge, right? based on this ICP algorithms, and also it's quite slow. So this is the limitations. Okay, the ICP will get diverge gradually. For example, okay, it's converge, 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 good, good. Okay, diverge from iteration 7. Okay, so this is the problem from based on those conventional algorithms from ICP. So tutorials, okay, tutorial provided in the Blackboard. Feel free to, okay, any questions, feel free to come to me, okay? Any questions, feel free to come to me. So limitations of the LiDAR scan, doing LiDAR scan in Python. So the first one, of course, is the performance, okay, accuracy and the concurrency on how to do parallel calculations. Laboratories, and for example, in Python, you have some toolbox to do this, but it's still limited compared with the ROS communities. Integration. So last one is like communities. If you get a issues, get the bugs, so you need to seek help from from the communities, right? But I mean, for Python, the community for Python-based learning is quite limited. If you talk about say stable plus a ROS-based community, is much larger for to seek help from. Okay, ROS. So I would say the ROS is a new word for the slang and unmanned autonomous system and artificial intelligence and ROS. Okay. So the ROS is so-called robot operation system. This is a framework that provides a collection of software libraries and tools to help developers to create robot applications. Like the slang is also one of the applications. Okay, simplify the process and accelerate your development procedures. So this is how much the people actually means how active it is, how popular it is. So for example, robots, okay, robots can like those six system functionalities like navigation, planning, control can all be deployed to ROS, okay, like the sensors, connections. So ROS is almost anywhere for the unmanned autonomous systems. So the key features. So I would suggest like, okay, let's start with the installation first, and then we can go back to enjoy all those features. Okay. Okay, so we have 48. Let's start with the installation. Okay, installation of the so the Liaison LIOS Liaison. So this is the algorithm I show you in my laptop just now about the SLAM algorithm. So let's start with the installation of the ROS. So what you need is a laptop with Windows operation, at least like 11, okay? Windows 11. So any of you is like lower than 11? No? Good. So at least 3G, 30G space, okay, gigabytes in your laptop, okay? So first we need to install a WSL. So in Windows, so this is a kind of virtual machine. So because if you want to install a Ubuntu system, okay, you need to have a virtual machine in your laptop. Second one is install ROS, okay, in a WSL. So then we can install the Liaison algorithms in your computer, download the data, run the Liaison algorithms, and visualize the results to replicate what I just show you, okay? What I just show you. So let's start with, okay, the step one is, okay, you need to do this first to install WSL1, WSL2, and step one. So if you are using a Mac, any Mac, okay, you're lucky, okay. Just one, okay. So try to install this uh ROS in your Mac based on the procedures for this page. Okay, so please install ROS first, okay? So let me know if you have any questions. Also, we have several TAs. Also, you can skip my slide, directly ask the DeepSeek to how to install the ROS as well, okay? Maybe DeepSeek will help you to provide the procedures in detail, okay? So again, install the WSL first, and then install the ROS in the WSL. So for example, from my laptop, so because my laptop already installed those stuffs, so input to say MD, okay, you get the terminators, right? You get the terminators, you can copy the code. So the physical meaning of this line is WSL list online. This means to show what kind of version you already have. So I would suggest like you can directly start with the step 4. Okay, directly start with step 4. You can see a lot of versions, right? And then if you look into those versions, okay, if you look into those versions, so here we have one key, like okay, one key 1804, which means the version. Usually we have like one key has like 18. Okay, so those are the most popular versions. Okay, the most popular versions. So for example, if you want to install a functionality, task over, okay, this one, okay, this one. Okay, implement this one. Okay, let's enter, okay, into the configuration of the software. So if you have questions, yes, here. So by today, at least you can finish the installation of Ubuntu first, okay? So and after the class, you can try to install ROS 1, okay? In Ubuntu 18 or Ubuntu 20. Okay, install the ROS 1. Okay, so this is the procedures of the installation of the ROS 1. So first you need to add the components, but this is kind of like very different. So we also download the very download the process. So this is install ROS. And if you are using 120, so this is the first motion. Data to the level. So how many of you have not yet installed? So if you have finished the one installation, so please install a ROS based on this page. Okay. So for installation of the ROS, no matter you are using the Mac or you're using Windows, it's the same. The procedure is the same. And if you have finished the installation of the Ubuntu and ROS, so try to check if it's correct or not. So in the slide, we provide okay, in page 88, we provide the example data, okay? Please download the example data. So this is the raw spec data. Okay, download this one. And try to use the graph to visualize the data inside the raw spec data. So click this one. Actually, this is a link. And also in the GitHub page, we also provide the SLAM data set. Okay, you can download this one as well. So in the GitHub repository, at the cover page, we have a link here, SLAM data sets. So this is data sets from Hong Kong. So you can download this. Okay, those spec files. Okay, we have some visitors already. So you can download the data and use the ROS to visualize the data. So by today, okay, as I just mentioned, as long as you can finish the installation of the Ubuntu, it's good enough. And later on, you can try to install the ROS after that. And yeah, if you want to learn more, okay, please ROS time. So that's because we have a little bit dependencies. If you know how to write a SLAM package from scratch, okay? Write a SLAM package from scratch. Based on ROS and without that. That is going to be much efficient. Okay, compared with Python, it's going to be much efficient. And also, if you want to learn more about ROS, you can just search ROS Wiki, okay? So ROS community provide a very good, okay, knowledge for us to learn about. So ROS Wiki is this year how to generate a ROS package from scratch. So this also includes the introduction, and also they provided the courses for you to run. I would say it's just perfect, just perfect. And each year, the ROS will organize conference. ROS is called ROS conference. Okay, each year. So if you are interested, you can also join this conference. Okay, 2024 is in Denmark. Okay. So wow, it's a big community. So those are okay. So 23 is 哦 2014 is in Hong Kong. So Rose conference in 2014 is in Hong Kong. It's very interesting. Okay, so the next conference 2025 is going to be in Singapore. Okay, so the Rose conference 2025. So as long as you get some papers or some projects, so get some papers, you can join this conference. You can join this conference. You can do another peers, another knowledge on those projects, on those communities. Okay, so that's all for today's lecture. So see you next week.